name is Eden. I'm the Chief Technician at Hudaco Energy. We are very excited about this journey. We have got so much pride in our products, which are designed with quality in mind, and also we want to make sure that our products are as easy as possible to install and to also manage. All right. So today's training is going to focus on Sungrow's high voltage batteries, which we call the SBR series. The SBR series is a family of batteries which can be built and be customized depending on a particular client's needs, right? So depending on the size of battery you need or the amount of power that you need, you can make the battery bigger and increase the size. All right. So when we say they are high voltage batteries, we mean to say they are actually not your standard 48 volt batteries, because most of the time, most of the installers were used to those brands like your Pylon Tech, your Shoto, which are 48 volts. These ones, the minimum, we started 168 volts going up. All right. So I'm just gonna show you a bit of a video, just an introduction video to this amazing product, and then we can get into our training there.
Eden, there is no sound on the video.
It sounds like the volume is very low. On my side, I've put it on 100%. I think it's just the way it was recorded. But I just want you guys to have a look at what is happening, then we can explain it later. All right, so that's our video there. Unfortunately, there was so that's our video there on the high voltage battery. Unfortunately, there wasn't a good sound there. But I got a picture of what it looks like and the components that it has. All right, so the main reason for having a high voltage battery is, I think everyone is aware that normally the higher the voltage, the higher the efficiency. So if you were to take, for example, a 12-volt system, it doesn't have the efficiency that a 24-volt system has, neither does it compare to a 48-volt system. So the whole idea of having a high voltage system is to try and make sure that you increase efficiency, right? So as the voltage increases, the efficiency also increases. That's the whole point of having a high voltage battery. Right. So let's just get right into our training and see the product as it is. Let me share my screen here with you guys. Can you guys see my screen there? Hello, can you guys see my screen?
Yes, Eden, we can see your screen.
All right, thank you so much. All right, so this is the battery, and this is, like I said, it's modular. When we say it's modular, we simply mean to say it is made up of pieces that you can join together to give you a desired size. So it can be stacked together in sizes from 3 to about 8 modules, right? So these actually connect in series, which then results in the addition of voltages. So the smallest is 3 modules, which is what you see here. The SBR 096, which is 3 modules, right? And that is the smallest. And the biggest is 8 modules, which is the SBR 256. Okay, so depending on how much power you need, you can choose any of these sizes, right? So obviously, you can see here, the codes actually have a meaning. The 3 modules will give you about 9.6 kilowatt hours. And each module is about 3.2 kilowatt hours. So if you stack 3, you get 9.6 kilowatt hours. If you stack 4, you get about 12.8. If you stack 5, you get something like 16 kilowatt hours, and 6, 19.2, and so on and so on. So these numbers here, the 096, 128, 160, 192, actually represent the kilowatt hours that you get from sticking together the different pieces of the battery. So you can't get anything less than 3 modules. Okay? And the whole system has got a lockable DC circuit breaker, and it is actually IP55 rated, meaning to say it has got a good degree of resistance to foreign objects and foreign material like dust and moisture, although it is not water resistant or dust proof, but it has got a certain degree of resistance to that. Okay. Let's just move on. Right. So the battery has got components. It has got components. The first component is the base. That's the one that sits on the floor. And then you've got your modules which stack up together on top of the base. And then you've got the top cover, which is the BMS or the battery management system, which actually connects everything into a functional unit. If you stack the modules together without putting on the top cover, the battery is incomplete. So it's like an open circuit. Therefore, it won't work, right? And then you also have the switch gear, which is the one that you saw slotting in on the side, but we'll see that in due course. And then you've got a slide cover, which then covers some small gaps that normally are created when you stack more than 3 modules. 4 modules and above, you will need what we call a slide cover. Right. So the base actually comes with rubber feet naturally, but these can be replaced with adjustable screw feet. The reason is it's not all surfaces that actually are conducive for certain environments, like the floors. You might find that you are using a rough floor, you don't want to use the rubber feet, right? So you might change that to use adjustable screw feet, right? Whenever you are installing, we recommend that you leave a gap of about 13 to 28 millimeters from the wall, with the arrow on the base pointing from the wall. So we'll see what it looks like. Right, on this diagram that I have here, that's where I'm illustrating that this is our wall, and you need to leave a gap of about 13 to 28 millimeters. And this arrow here is actually there on the base. So that arrow there needs to point away from the wall. The reason why we leave this gap is obviously for ventilation, and the other thing is around here you need to leave some gap for a bunch of cables that will then come in for connection with the inverter, connection with solar panels and everything else. So there's need to leave that that gap there. All right. So, but don't forget that this arrow must be pointing away from the wall. Okay. Then let's proceed. So these are the major components of the battery. A is the base, all right? This is the base, which I said must be on the ground. It has got adjustable feet, or you can leave it with its rubber feet, all right? And the arrow, like I said, must be pointing away from the wall. And then after that, you can then stack up your modules, which we said can range from 3 to 8 depending on your power requirements. All right, each module there, as you can see, has got 2 handles, which means it can be carried by 2 people because it's actually quite heavy. It's about 33 kgs each. So if you have got 3 modules, then you're talking about almost 99 kgs of mass there. So it's quite massive. All right, that's the reason why it has got those handles that are there. So it's quite heavy, about 33 kgs. We don't advise a person to carry it alone, although you can if you've got the muscles to do so. All right, and then this is the top cover, which we said contains the BMS, which then connects everything else to make sure that the battery system is functional. And then this is the switch gear, which slides on the side. You see that groove there on the modules. So it slides in on the side once you've stacked up everything. And this is the slide cover that I was talking about when I said if you're stacking from 4 modules and upwards, you're going to have some little gaps like this one here that will be on the battery. So you need some covers there to just cover those gaps. All right, so those are the major components of the battery system. Like I said, this slide cover, you don't need it as long as you're using 3 modules. But the moment they become 4 and above, you need the slide cover there. Right, so here let's look at what we call the switch gear. The switch gear has got five important components there. We've got the communication part, which is number one, labeled on our diagram there. This is used to enable communication between the inverter and the battery. And also, when you have got a number of battery banks which are connected in a daisy chain, you can use that communication port to link each battery to the next. All right, so these batteries are actually able to communicate with each other, just like your normal lithium-ion batteries. All right, then port number 2 is your negative terminal, which connects to the inverter, and the positive terminal is P plus number 3, which connects the positive on the inverter. Right, and then you have the grounding terminal, which then connects to the ground on number 4, and 5 is the DC circuit breaker, which powers on or off, or it acts as a disconnect, and also for short circuit protection of the battery in case something goes wrong. That is the function of the DC circuit breaker that is on the side there. All right, so that's basically what the switch gear system looks like. Right, here I've got a diagram of the delivery scope of the battery system. So inside the box, these are the items that you will see inside the box. All right, some of them you've already seen them, like your base, the modules, the top cover, the switch gear, and the slide cover there. All right, this bracket is for mounting the battery to the wall to avoid unnecessary movement. And this part G, we call it the harness. The harness actually has got oil cables that connect to the battery. And H, we call it the stud. We'll see in due course what it does, but it's basically more like a screw, but it's a special screw which holds the battery together. And these are screws, some which you can use to mount into the wall, and also they are the metal screw feet that I was talking about that you can use to replace the rubber feet. Okay, so very, very important when you receive this, those are the items that you must see. And of course, your N is the documentation with instructions on what to do and how to safely install the battery. All right, so when installing, as I have mentioned already, that each module weighs around about 33 kgs per module, not for the whole battery, but per module. So the minimum weight that you'll be talking about, excluding the base and the BMS, just for the modules, is about 99 kgs. All right, so this is quite massive, as you can see. It needs to be handled with great care. And as I've said earlier, you start with your base with an arrow pointing away from the wall, and then next you put your successive modules depending on how many they are. They actually slot into each other easily. Within a few minutes, you'll be done putting everything together. So it's quite an easy process to just get it in place and connect it. That is the whole idea of most of our products, to bring, simplicity to the whole process of installation. Otherwise, we don't want you spending a lot of time on site trying to figure out so many things. And also this battery, it gets automatically detected by the inverter. You don't have to say you do certain settings or you input certain parameters on the inverter for you to get this battery to be detected. So it's quite a time-saving kind of arrangement when you're dealing with this battery. Okay, to our next slide. Right, so this is what it will look like. And so here I'm just showing you how to assemble it. So we've stacked together all the modules, about 4 of them in that, on top of their base. All right. Once we have done that, there are screws that you need to put in on either side of each module. You put in screws to fasten them together. Just make sure that they don't easily slide over each other. All right. So you put in screws, which then hold them together. And please take note of the torque, which is here, 2.5 Newton meters. You shouldn't over torque them, otherwise it could result in undesirable results. So just apply a reasonable torque to make sure that you still leave the battery system intact and secure without any problems. Right, so on either side of each of the modules, you need to fasten with a screw, and also make sure that you use the right screwdriver. The size is very important, the M5, right? Because if for some reason the screws are damaged and at some point you might need to remove one of the modules for some reason, you might have problems if you can't unscrew it. Okay, so after sticking together the modules and screwing in the screws, we now have to slide in the switch gear. So it will slide in from the top down to this point where it connects with the whole system. Then it starts communicating with the whole system. Right, so after all these modules have been stacked together, you then slide it in. All right, so I think as you can see, I think I also explained it earlier on, this switch gear will actually slide down and naturally cover the first 3 modules, which means the top successive modules from the 4th one going up will be left with a gap that is not covered by this switch gear. All right, that small gap is where you put in the slide cover, just to cover that gap in order for it to look neat, and also just protect the system from any objects that might just be thrown at it. All right. Now we have slotted in. This is what I was explaining just now. We have slotted in the battery, the switch gear. This is for 3 modules. You can see it fits perfectly well, and it gets right to the top. So there's no gap left, right? And you put in the stud, that other special screw which I told you about. That is where it goes. It holds the switch gear to the last module that is on top, right? But if we are now using more than 4, you now see what I was saying, that there's gonna be a small gap, which is this one, that is created due to the existence of that 4th module or any other successive after the 4th one, right? That's where you put your slide covers. All right, again, the torque and the screwdriver size are very, very important components of this installation process. Otherwise, you don't want any undesirable results there. The next part, I think you saw earlier on this, on this slide here, I think you can see these lines, these 2 lines here. These 2 lines are there on every module. All right, those are the lines where you fit in the wall bracket. Right, that is where you fit in the wall bracket. The wall bracket has got no structural significance or importance. It's just for you, it's just meant to force you to never move the battery too close to the wall. That is its function. So it's not strong enough to hold the battery above ground, but its function is just to make sure that once it's mounted onto the wall, then it doesn't allow the battery to move any further towards the wall. So you start by making sure that your bracket is mounted on the wall using an M4 screw with a torque of about 1.5 Newton meters. All right, and from there, you then push your battery under the bracket where it actually aligns with the bracket, and then you mount these screws, which are M5, slightly bigger, and then you apply a torque which is slightly higher than the one that you used on the wall. Right. So this must not be mistaken for something that will mount the battery to the wall and hang it there. It's not for that. It's not like your other lithium-ion batteries. This is for making sure that the battery doesn't shake or cannot be pushed towards the wall further than the recommended gap already that we have spoken about of 13 to about 28 millimeters from the wall. Right. And this is our switch gear. Our switch gear, as we communicated earlier, it has got a part for comms, there's a part for positive and negative, then it has got a part for the earth cable. So if you want to achieve communication between the battery and the inverter, you have to use the comms cable, and for that we use the orange white and the orange strands on the RJ45 cable. So this is very, very important. Although people can just swap these things around, but we don't recommend doing so. Usually we recommend that you follow the standards. All right. CAN 1H is red and white. CAN 1L, it's orange and white, and CAN 1L, it's orange. So that must be followed. Otherwise, at some point, it will give rise to some confusion in case someone else to maintain the system you installed, or some other changes have to be made. Right. So you just strip the insulation layer of the communication cable with the wire stripper, and then you expose the two cables that I've mentioned, and you make sure that you put in those, you select those two strands, the orange white and the orange, and put them up for communication on the inverter and also between batteries. Right. So when you are taking a cable from, say, the battery to the inverter, the connection between the battery and the inverter, that is your P plus and P minus. We have got a very innovative type of connector which is called the SunClicks. The SunClicks is more like, it's just an MC4, but inside, instead of crimping the cable onto the lugs, you have got a connector which we call the SunClicks. So what does it do? You simply open this, all right? You simply unscrew this, and after unscrewing it, you push in your cable. After pushing in your cable, you use a screwdriver or some other object to pull this down, and then it clicks into place and holds the cable, and then you screw it up, and then close and lock. That's how simple it is. You don't have to solder anything. You don't have to crimp anything. You just do a very simple process. Push in the cable. After pushing in the cable, you pull down the SunClicks connector. It has got sort of a lever mechanism, and then it holds onto the cable. When you want to remove the cable, it's no longer a difficult thing. It's just the reverse of what we did. You simply take a screwdriver. After unscrewing the connectors, take a screwdriver, lift up the SunClicks connector, and pull the cable out. That's very easy, right? So as I mentioned earlier on, that the whole idea of most of our Sungrow product is to make work as easy as possible, right? Most of the crimping equipment that we use, once you crimp, it means you have to cut it off, cut the cable off, and then restart the whole process. But this one, you just slide the cable in and then pull down the connector so that it fastens on the cable. And if you want to remove it, you just do the reverse and then you're sorted. Right, for this, we can use a normal PV cable, 4 or 6 millimeter cable. So you don't have to have those very thick cables that we normally see with other batteries. You can just use the 4 or 6 millimeter cable. Right. This is what the connections will look like on the switch gear. You've got your earth connection, which is that yellow-green wire. And then you've got your battery plus and your battery minus, and then your RS45, which is the comms cable. So it will look like that. And that's the reason why we were saying here, this bracket is supposed to force the installer to leave a gap. Why? Because this whole bunch of cables will need some room behind the battery to go behind the battery and go wherever they are going, to the inverter or some other components. All right. So the whole point of having this bracket here is to make sure that your battery leaves a reasonable gap between itself and the wall, which will then accommodate any connections and cables that need to be installed on the system. So sometimes some people would prefer to put it in a Sprague tube, put all these cables in a Sprague tube. So if you put them in a Sprague tube, it means if this battery were too close to the wall, then you'll have to move it. And sometimes it's not going to be easy to do that given the weight of the battery. Imagine having to dismantle the whole battery of 8 modules, for example, just so that you can pull it and then put cables. All right. So that's the logic of having this bracket, to just restrict the distance between the battery and the wall for the sake of the cables that you put in. Right. After installing everything else, we now put in our BMS, or the top cover, which is brown there on our diagram, and then we fasten it with our 2 screws on either side. Also, the torque is very important, and screw size is very, very important there. So like I said, until this point, until you reach to this point, this battery does not turn on because it doesn't have a BMS. The BMS is contained in the top cover. So it's like an open circuit when it's without the top cover. All right, so it's very important that the top cover be put after everything else is done. It also gives you an indication of the state of charge of the battery. Right? This is what the slide cover will look like once you have got 4 or more modules, as I said earlier. So they cover those small gaps there so that you make sure that there is no room for any foreign objects to get inside the battery. All right, so very, very important. If you are ordering 3 modules or less, like I said, you don't need those side covers. All right, but if you've got 4 or more, you need them. All right, but it doesn't mean that they won't be supplied in your package. They can be supplied in your package, but they won't be necessary after all. So this is the top cover that you see here, the white part here that you see. The top cover has got 2 parts which both act as indicators. You've got the one on your left there with those bars there. It's a state of charge indicator, right? So each bar represents 10% state of charge. If your battery shows 1 bar, it means it has got 10% power. If it shows 2, 20%, 5, 50%, 7, 70%, 10 of them, it's 100%. It means your battery is full. All right, and this is the power button on the right of the indicator, of the power indicator. It's a touch button. It's not a push button. It's a touch button. So you simply touch it, and then the battery turns on. So if it shows a solid blue, it shows that the battery is operating normally. But if it's showing a red light, then it means there's a fault somewhere, maybe with your connections. There can be a fault with any of the things on your connection. So this is a touch button. It's not a push button. The moment you touch it, it then turns on your battery, provided that the switch gear breaker is up. So this doesn't override the switch gear breaker. The breaker must be turned on first, and then the touch control will then be used. Right, so this is just about it regarding the battery. We have covered quite a number of things. I was fast, I know. This is just to save time for those who are busy and leave time for people who would want to ask questions. But before I allow you to ask questions, I might just need to ask you a few questions from what I've presented. So I would say maybe we need to, those who want to ask questions, or those who want to respond to my questions, you can unmute yourself and then give your answer, then mute yourself again. Right, so on the questions, we said how many modules can be stacked in a Sungrow battery module? How many? Minimum and maximum. Just to check your knowledge there. You can raise your hand or send your questions to the chat. As suggested by Daniel there. James?
I don't think I can answer. I think that's cheating if I answer.
Okay, there's who is that who sent a question? They said, can the batteries be paralleled? Yes. Like I said, they can be paralleled. But before we get to that, please, guys, answer my questions that I'm asking you before we get to your questions. This is just for me to check if you understood what we were doing, right? I said how many modules can be stacked in a Sungrow battery module? How many? All right. I don't seem to see any. I don't know. Maybe it's on my side or what. I don't seem to see any responses there.
There are a few correct responses, Eden. We do have some. Johan, Eugene, and then Hardis also raised his hand. So
Okay.
Correct response.
So we do have responses. All right, so the correct answers are 3 to 8. All right? It's 3 to 8, like we indicated earlier, that the smallest is 3 modules, which is 9.6 kilowatt hours, and then the biggest is 8 modules, which is your 25 point something there. That is the range of modules. So anything below or above that, you can't actually put it together. All right, and the next one is, what settings are required on the hybrid inverter when the battery has been connected? What settings are required? I explained this. Who's going to give us an answer? Right, I said.
Eden, I'm not sure if you can see, but Eugene has answered in the chat.
I don't see the chat on my side.
Aha. So it is the correct answer. There is no need for settings. It will auto-configure itself.
Yeah, so the inverter will actually just detect the battery once everything has been set up correctly. You don't need to play around with any settings in order to make the system work. All right. Then the last question on my side is, what will happen when the battery is initialized for the first time? This one I didn't explain it. But what will happen is, when you initialize it for the first time, the first 10 seconds, your battery will be initializing, flashing the blue light on the touch control. And then once the flashing is done, it then stops and shows you a solid blue light when everything is in order. If it's not, then it will show you a red light. Then you know there's a problem somewhere. All right, so those are all the questions that I had, which I thought we could just ask in order to check your understanding, and also maybe maybe address that. Okay, now let's go to your questions. I don't know what I can do, Daniel, to...
Eden, I can read them to you. We've had 2 questions so far. The first from Stefan Lombard, asking, can the batteries be paralleled? The second from Martin, asking whether the Modbus protocols for the battery management system are available. Those are the 2 questions we've had so far. So the first one from Stefan, can they be paralleled? And the second one from Martin, asking, are the Modbus protocols available? Martin, I'm assuming you're referring to the batteries themselves as opposed to the inverters. The response from Martin was yes, referring to the batteries themselves. Maybe we should deal with that one quickly. Martin, just to say, the Modbus protocols for the batteries are not available to us at this point. I see Bertus is online from Sungrow. Sungrow may make it available at a later point, but at this point, they are not available to us. They're for integration with the Sungrow products directly themselves for now.
Yeah. All right, so in terms of being paralleled, yes, you can, the batteries can be paralleled together. That's what I was explaining earlier, that your comms can be used for communication with the inverter or for connecting the batteries in a daisy chain kind of setup. All right, so yes, they can be paralleled if there is need for that. All right, any other questions?
No more questions from now, Eden. If I can, maybe from my side, if I can just take a couple of minutes to discuss a couple of things regarding the technical aspects of the battery from a commercial side. So I think to start from Hudaco Energy's side, thank you to everybody for attending and participating, and thank you to Eden for presenting. I think it was clear, I think it was concise. I think there's a couple of aspects on these batteries which are really, really important. The first one is that it's very fast to install. You're probably, once you've done it a couple of times, looking at about 15 minutes, 15 minutes to actually get the physical portion down. It is that simple. You know, we went slide by slide, but in real life, in reality, you would probably take the same amount of time as the presentation to get it done. The second thing is, because it's high voltage, ranging anywhere from, say, 50 up to 400 volts, the cabling and the protection mean that you don't need to add anything else in. So you bring it out of the batteries, you've got a red, a black cable, a comms cable, and an earth cable, and that's it. So your time on site is incredibly far reduced, and you need one, maybe two people. I think we recommend two just to keep everybody's backs safe, but it is possible for one person to carry and install the entire battery system themselves. And that's very, very flexible. So one of the big advantages of this type of a system is your time on site is massively reduced, and your requirement to go back to site is incredibly reduced as well. We haven't presented on the actual commissioning of the inverters, but that's just as simple. It's wireless, it's done on the cell phone, and basically you press the one button on the front of the batteries. 10 seconds later, it comes online, initialized, and you configure your inverter. So not only is it incredibly fast to install the battery system, but the matching inverters, whether single phase or three phase, is just as fast, and in and out, excluding obviously your mounting structures on the roof and your module installation, but the actual inverter and battery in and out in an hour, once you guys are used to it. And that's a huge advantage for you as an installer. So even though we haven't discussed that because this is a technical presentation, it's really important to keep that in mind, I think, for everybody as you're considering this type of solution for your customers. With that, thanks very much from my side. Eden, back to you.
All right, I think that's it for now. Our presentation ends here, unless if there's any other questions that could probably have come up, and also maybe from the guys from Sungrow, if you've got something to say, please, we can give you the opportunity to contribute something. Otherwise, guys, feel free to contact us, and in case you've got any other questions, you can contact us, contact our sales team, our technical team. Would be very glad to attend to all of your issues. And like I said, at the center of our desires is to make sure the work is very simple, and you spend the least time possible on site doing all the work, as James has been saying. So thank you very much, guys. I hope you do well, and let's keep in touch.